Hi everyone, my name is Jasmin Breitenstein, and today I want to talk to you about our work on joint prediction of Amodal and visible semantic segmentation for automated driving. So why do we first look at Amodal semantic segmentation? So we're interested in basically segmenting objects behind occlusions, which is of course crucial for safe environment perception. And in our work, we train Amodal and visible semantic segmentation separately and jointly, and we find that the joint training actually can improve upon both tasks. What does our method look like? And we can see this here. So on top, we have the standard semantic segmentation in blue. At the bottom, we have the separately trained Amodal semantic segmentation in red, which actually is just the normal semantic segmentation network trained on the Amodal ground truth only. And then here we have the shared and the joint training using a YNet structure where the encoder is shared, and we have two decoders giving the Amodal and the visible semantic segmentation. All are trained using a cross entropy loss. In the joint method, we weigh the cross entropy loss equally. And also in the joint method, the Amodal ground truth is used for training the Amodal part. And our network of choice is the ERF-net. So now some background for our experiments. So we use the Amodal cityscapes dataset and the standard cityscapes dataset. We evaluate using standard MIU and invisible MIU, which is just the MIU calculated wherever Amodal ground truth is available. And for our results, we can see them here. So up here we have the results of the standard ERF-net, the visible semantic segmentation. We can see that the separately trained Amodal network, of course, also already improves the invisible MIU, also by quite a lot. But if we look at the YERF-net, we can actually see that this improves even more, and moreover, as shown by the bold results, we can actually get improvements in all metrics. This also holds for the per class invisible IUU, which we can see down here by the bold numbers as well. It's just one class, a bicycle class, where the Y method is not as good as the separately trained one. But we can see that especially for the vulnerable road users here, person and rider, invisible MIU improves quite a lot in the joint training. So what does it look like in practice then? So here we have some qualitative results for this input image with this car occluding this person here. And we look behind mobile objects. Mobile objects are objects that have the ability to move, and the Amodal networks are trained to predict Amodal areas behind inserted occluders, which are just these mobile objects. You have up here the separate training approach, and down here the joint training approach. And we can see here the relevant parts. So behind the mobile objects, when we look at the Amodal predictions, we can see the occluded person behind the car is anticipated by both methods. And the joint training down here actually recovers the full person shape much better. And we should note that this would be a rider, which can not be anticipated from just the head in this image. For conclusions, all methods allow the prediction of separate classes, and as we've seen, the single-task Amodal semantic segmentation improves Amodal performance. However, the joint training improves both Amodal and visible semantic segmentation. So this was a short poster presentation of our paper, and I'm very happy to discuss this further with you. Thanks.